Welcome back, student. Today we are going to see the minimization of DFA example 2. Okay, in the last class we did the minimization of DFA. Okay, and today we are going to see one more example on this graph. Okay, this transition graph, or you can say state graph. So today we are going to see on this, and what is this? This is a DFA graph. So just quickly I will review what we have done in the last class. In the last class, we saw why we need to use the minimization of DFA. Okay, example here I gave you, like if one person is finishing the DFA in 5 states, other person can be complete in 4 states. So the 4 is the best. So for that reason, whatever the DFA we have, we need to check, can we reduce or can we minimize the number of states. So based on that, we need to uh, minimize with the help of equivalent method. Okay, and we change to minimization DFA. And the equivalence, there will be a 0 equivalence, 1 equivalence, 2 equivalence, 3 equivalent, and so on, and equivalent. So in the last class I told you, like state input string is the next state. So here delta a comma x is belongs to final state, and delta b comma x belongs to final state. If both are same, then it will be a equivalence. Okay, that will be a equivalence. A and B is a equivalence. Or delta a comma x does not belong to final state, and delta b comma x does not belongs to final state. That also is a equivalent. If some state is going to the final state and some state is not going to the final state, if both are going at the same destination, then it will be a minimization equivalent. Okay, so we did the in the last time this example. With the help of this example we finished that. Okay, and if it is normal x, that means string. Here I use the only x, that means string 0 or 1. Here if you have the mod x, then it is a length of the string. Okay, what is the length of the string? 0 equivalent or 1 equivalent or 2 equivalent, we will see that. Okay, so today we will see on this equivalence method. So last class we did this. Okay, this DFA we make like Q A B C D E, sigma is 0 comma 1, Q0 is A, F is E. So we make a transition table for that, and after that we found the equivalence. How we will need to find? First, both states should go to the same state. Example, like take A and B. A is going to 0 is B, B is going 0 is going B on 0, we are getting B. The B are same. Next one is all should be in the same set. Means, can you see here, one set, one set, two set, three set, that should be in the same set. That also condition needed. So this is a normal DFA, and this is a after doing minimization of DFA. Okay, fine. So today we are going to see this. Okay, so now first you need to draw the transition table. For that, Q, what is Q here? A, B, C, D, E, and F. 6 state we have. Okay, and what is the sigma? Sigma we have 0 and 1. 2 strings are there. Okay, and what is the initial state? Initial state is A. Q0 is A. Okay, what is final state? Final state F is C, D and E. C, D and E. These three are the final state. Okay, and what is the transition table for this? Transition table 0, 1. Okay, and what is the first one? We need to take the A. From A on 0, where it is going to B. A on 0, where it is going to B. A on 1, A on 1, here, A on 1 is going to C. Okay, next one is B. Next one is B. B on 0, where it is going? B on 0 is going to A. And B on 1 is going to D. Okay, fine. Next, C. C on 0, where it is going to E. C on 0 is going to E. C on 1 is going to F. Okay, and what is D? D is from D on 0 is going to E. Okay, D on 0 is going to E, and D on 1 is going to F. Okay, now E. E on 0, where it is going? E on 0 is going to itself, E. Okay, and E on 1, where it is going? E on 1 is going to F. Okay, next, F. From F, F on 0, where it is going to F only, here, F. F on 1 is going to F only. So we finish all the state and we draw the state table. Okay, and what is this? This is a delta. Okay, fine. Now we need to make a equivalence. Okay, we need to make a equivalence. How to make a equivalence? First you need to do the zero equivalence. Zero equivalent. Okay, zero equivalent. What is zero equivalent? That is very simple. Here zero equivalent means you need to separate the final state and the normal state. First step, what is the first? A is a normal state and B is a normal state. Okay, C is a final, D is a final, E is a final, and F is a normal state. So this is F. This is one set. The next set is final state. What is the final state? C, D and E. So this is zero equivalence. Okay, next, one equivalence. What is one equivalent? One equivalent. Now we need to take zero equivalent is the input and we need to get the one equivalent. Okay, so how to do? First you need to check A comma B. Okay, first you need to check A comma B is the equivalence or not. Let's check. A on 0 is going to be okay, and B on 0 is going to A. B and A. Okay, these both are different. Okay, next, A on 1 is going to C and B on 1 is going to C. Okay, so here we will get the answer. So here A on 0 is B and B on 0 is A. Okay, A and B, just check here. Here, okay, so here A on B, A on 0 is B, B on 0 is A and B both are in same set. Okay, next A on 1 is going to C, B on 1 is going to D. Now check here, C and D is also in same set. So here, if both are going to the same, if both are not going to the same destination, but the second condition is very important, that should be in the same set. That means A comma B is a equivalent. Okay, why it is equivalent? But A is going to B and B is going to A is going to C and B is going to D. All are different, but how it is equivalent means whatever it is going, A is on 0 is going to B, B on 0 is going to A. These both are in same set, AB. Okay, and here in it is, when it is taking one is a input, is going to C and D. Here also both are in same set. So because of that, A and B is a one equivalent. Okay, now the next one we need to check F A. You can take AF or BF, so you can check any one of this. Okay, I will check A and F. A on 0 is going to B, okay, and F on 0 is going to F. BF, check BF in the same set, BF in the same set. Okay, yes, fine. Next, A on 1 is C and F on 1 is F. Just check F and C is in the same set. No, this is in the different set. So now F is not a one equivalent. Okay, this is separate now. This is not one equivalent. Okay, only 0 is in the same set. When it is going to 0 in the same set, when it is going to the A on 1 and F on 1 is in different set. So this is okay. Now next one is, now the next one, okay, so here now we need to do the same operation what we did here. C on 0, C on 0 is E and D on 0 is E. Yes, both are same and E is only here only. Okay, next, C on 1 is F, D on 1 is F. Means C and D, C comma D is a one equivalent because both are going to the same state and in the same set only. E is in here, F is here. Okay, next, you can take any one, E on D or E on C. Okay, so I will take D, anything. So I will do D and E. D on 0 is E, E on 0 is E, E. Both are same. Okay, fine. E. Now D on 1 is F, E on 1 is F. So C, D, comma E. These three all are one equivalent. Okay, so this is one equivalent. Next, we need to check two equivalent. So here first check AB. A on 0 is going to B and B on 0 is going to A. Yes, A and B in the same set. Now you need to check this one. Now you need to check this one. Two input, for the two equivalent input is one equivalent. Okay, A comma B, yes, in the same set. A on 1 is C, B on D, B on D. Sorry, B on 1 is D. So C, D in also a same set. So that means A comma B is a equivalent, two equivalent. F is a single, so just take it as it is. We no need to find the equivalent for the F. C, now C on 0 is going to E and D on 0 is going to E. Okay, so here both are going to the same. Now C on 1 is going to F, D on 1 is going to F. So this C and D is a equivalent, both are going to the same state. Okay, now D on 0 is E, E on 0 is E. Yes, both are going to the same, fine. D on 1 is going to F, E on 1 is going to F. That means CDE is a two equivalent. Now you can check, this and this is same. Whenever we get the same, you need to stop here, okay. So here stop, and this is a state, the new state we got. What is the new state now? Q is A comma B, okay, F and C comma D comma E. Okay, this three state we got it. Okay, on the sigma 0 comma 1. Okay, and what is the initial state here? This is as per the table, this is the initial state, and final state is C, D and E. Okay, so this is DFA to equivalence of this DFA, MDFA, minimization DFA, deterministic finite automata. So this is a output. Okay, so here based on this we will make a table. Okay, we make a table here. I will make here. Okay, so here the delta 0 and 1 input. Okay, sorry, here first what is the initial state? A comma B, A comma B. A on 0, check the table, A on 0 is going to B, B on 0 is going to A. Okay, so here we will, so here A comma B. Okay, now we need to do one by one. A on 0, what we are getting? We are getting B. We change the color, B. Okay, and B on 0, what we are getting? We are getting A comma B, we got it. Okay, next A on 1, what we are getting? We are getting C. Okay, A on 1, we are getting C. B on 1, we are getting D. Okay, next A comma B. Okay, next one is F. Next one is F. You can take F or you can take C, D, E in the sequence. Is up to you, whatever you want to take. So I will take C, D, E. Okay, in the C, D, E, C on 0, what's the answer we are getting? We are getting E. Okay, we are getting E. D on 0, what we are getting? E only. E on 0, what we are getting? E only. So E is a answer. Okay, next. C on 1, C on 1, what we are getting? We are getting F. And D on 1 is going to F only. So here only F. E is also going to F only. And the last one is F. Here F on 0, F on 0 is F. F on 0 is F. F on 1, F on 1 is F only. So this is our final graph. Okay, this is a final graph. Fine. So okay, so this is a transition table for the minimization MDFA. Okay, so we will make a state diagram for this. What are the Q states? A comma B. First I will do one thing, just scroll down. Okay, now I will make here A comma B. A comma B is one state. A comma B is one state. Okay, next is you can take C D E is one state and F is a one state. Okay, this is a 3 states are there. Okay, let's take A comma B on 0, where it is going? Is going to 0, is going to AB only when the input is 0. Okay, next A comma B on 1, where it is going? A comma 1 is going to A comma 1 is going to okay, so here we need to make like this. Here should be C comma D comma E. Why we need to take E also? Means we don't have the state CD comma E, because whatever state we have here, that only we need to take here. Okay, so for this C comma D comma E. So A comma B on 1, where it is going? Is going to C comma D comma E, is going to C comma D comma E on the input 1. Okay, fine. C comma D comma E on 0 is going to E. So where is E? So whenever we are getting like this, only I took E and F. Whenever you are getting like E here, so if it E state we don't have here. Okay, so we need to take full state whatever we are taking. So what we are taking? E, where it is? C D E, C comma D comma E. Okay, we need to take C comma D comma E. So here what we are getting? If it is 0, is going to C D E. Okay, and C D E on 1, where it is going? Is going to F, is going to F when the input is 1. Okay, next F on 0 is going to F only. Okay, and F on 1 is going to F, 0 comma 1. Okay, so this is a final answer. Okay, this is a MDFA. Okay, so I will quickly tell you I will quickly summarize this, then it will easy for you. So here this is a graph. In this graph, it is a DFA graph. Okay, this is DFA graph. In the DFA graph, we have the Q, A, B, C, D, E, F. Sigma is 0, 1. Q0 is A, F is C, D, C, D, E, final state. And here we make a transition table for that. The main important thing is we need to check the equivalent A, B, F. First step, what is the first step? First we need to take the normal state and final state. Here normal state is A, B and F. We make in the one set. C, D, E is the final state and we make in another set. Okay. Next one is a one equivalent. In the one equivalent, we need to check A, B is a equivalent or not. How? With the help of transition table. A on 0 is going to B, B on 0 is going to A. Both are not same, is A and B. But now what we need to check, is it in the same set? Yes, A and B is in the same set here. Okay, A, B in the same set. Okay. Next, A on 1 is going to C, B on 1 is going to D. CD is in the same set? Yes, in the same set only. So for that reason, A, B is a equivalent. Okay. Next, we will take A, F. A on 0 is going to B, F on 0 is going to F. Let's check B and F in the same set. B, F, yes, it is in the same set, fine. A, 1 is going to C, F, 1 is going to F. F and C is in different set. So that means F is not equivalent to A as well as B. So just close this, separate it. Okay, next C. Let's check it out. CD. C on 0 is E, D on 0 is E. C on 0 is E and D on 0 is E. C on 1 is F, D on 1 is F. Yes, both are equivalent. C, D. Now check with the E. D on 0 is E, E on 0 is E. Okay, E. D on 1 is F, E on 1 is F, E. So C, D, E. So this is one set. Okay, this is one equivalent. Now do the two equivalent and take one equivalent is a input. Okay, A, B. Let's check it out. A, B. A on 0 is B, B on 0 is A. Yes, these both are in same set. Fine. A on 1 is C, B on 1 is D. So here CD is also in same set. So that means A and B is two equivalent. Next, F is a single, as it is we will write. Here C, D, E. C on 0 is E, D on 0 is E. That means both are going to the same and CD. So because of that, CDE is a two equivalent. So here we need to check the above answer is same as current answer. That means now you need to stop here. You don't need to go further. If you go further also, you will get the same answer. Okay. So how many Q states are here? Q is equals to A, B is one state and F is a state and C, D, E is one state. And what is the sigma? Sigma is 0, 1. Okay. Sigma 0, 1. Okay. So we will make a transition table for that. A, B, is 0. Based on this we will get A, B, A on 0. A on 0 is going to B. B means, do we have B? Here we combine A, B. So directly you can write A, B here. Okay. Directly you can write A, B here. Next, a comma b on 1, a comma b on 1 is going to c. So c is a separate set? No, c d e is mixed, combined. So for that we have taken c d e. Okay. Next, c d e. C D E on 0, take any one of this, C, D or E. C on 0 is E. E means is going C, D, E. We don't have separate set E. E is combined with C, D. Okay, so we write C, D, E. This is E. Okay, this is E. And C on 1, where it is going to F. Okay, is going to F. F is single state. F on 0 is going to F here, and F on 1 is going to F. So this is a transition table. Then after that we draw the graph, state graph, A comma B and C comma D comma E and F. Here A B on 0, what the answer we are getting? We are getting A comma B. Okay. A comma B on 1, where it is going to C D E. Okay. C D E on 0 is going to C D E only. C D E on 1, where it is going to F, when the input is 1. F on 0 is F, is going to F only. F on 1 is going to F only. So this is a final answer. I hope you understand this. Okay. Okay, I hope you understand. So this is about minimization of deterministic finite automata. Okay, MDFA. In the next class we are going to take one more example and another method. We will solve that. Okay, thank you.